target. Describe how to evaluate the 6 trigonometric functions using the unit circle. All right, so we have already learned about 3 trig functions called sine, cosine, and tangent. Right, but our target today says describe how to evaluate the 6 trigonometric functions. Well, we already know how to do 3. Thank goodness. We know that in a unit circle, that sine of theta is equal to y. Right, our sine is our y value in the unit circle. That cosine of theta is equal to x. And that the tangent of theta is equal to your y value divided by your x value. And x cannot equal 0. Because that would give us a 0 in the denominator, and we don't want a 0 in the denominator. Right. Well, guess what? There are 3 more trig functions out there that we need to be aware of. And that's what we're going to spend, well, actually, we're going to spend time on both today, but that's the new thing that we're going to learn today. Do you know what those are? The what? The negative sign, which would be the inverse, right? Do you know what their names are? Well, in the calculator, that's what it looks like, yes. But they actually have official names, like we have a names for sine, cosine, tangent. So there are 3 more trig functions. That we need to be aware of. They are cosecant. Probably learned about these in geometry. Cosecant, which abbreviates as CSC, cosecant. Secant, which that abbreviation is SEC. And cotangent. And that abbreviation is COT, cotangent. So we have cosecant, secant, and cotangent. Okay, so let me show you what this means. I'm going to make a little box. We know that the sine of theta is equal to y, right? Well, the cosecant is the inverse of sine. So the cosecant of theta is the inverse of sine. So that means it would be 1 divided by y, or 1 over y. So if you know what the sign is, the cosecant is 1 over whatever the sign is. Okay? So if you know the sign, cosecant is 1 over whatever the sign is. We know the cosine of theta is equal to x. Well, the secant of theta, what do you think that is? 1 over x. I wish cosine and cosecant went together. It'd be easier to remember, but it doesn't. Sine and cosecant go together, cosine and secant go together. And then tangent does go to cotangent. So we know that the tangent of theta is y divided by x. The cotangent, I keep saying inverse, I mean to say reciprocal. The cotangent of theta is the inverse of tangent. So instead of y divided by x, it's x divided by y. Notice the trig functions are inverses. Do it again. Not inverses, reciprocals of each other. Reciprocals. I kept saying inverses. I meant to say reciprocal. All right, y'all pull it out. Anybody still writing? All right, so let's do an example. Example 1. I am going to draw a circle. A unit circle, if you will. And I am going to draw an angle that intersects my circle at point P. Okay? And so my angle, I'm going to call my angle T. I don't really know what my angle is right now. We could figure it out when I give you a little bit more information. But I'm going to tell you that point P on the circle equals negative 1/2 from the square root of 3 over 2. Could we figure out what the measure of angle T is? If I know that order pair on a unit circle. But I could, right? But since they already gave us that information, we don't really care what the angle measure is. Okay? If they gave us the angle and we had to find the ordered pair before we could find the 6 trigonometric functions, which is what we're going to do, then we would do that. But they already gave us that, so I don't really care what the angle is. All right? So then I can take, use the figure to find the values of the 6 trig functions at P. All right, so first of all, let's find the sine of theta. Things are T, so we're going to say sine of T. Okay, they labeled the angle as T, so we're finding the sine of T. Well, do we have to do any work here, or can we just tell what the sine of T is? What did we say last class? Cosine is your what? X, and sine is your y. So they gave us the ordered pair. So what is our sine, or our y? Square root of 3 over 2. Boom. Okay, not too bad so far. So now let's find the cosine of t. Did they give us the cosine?
Yes.
What is that?
Negative 1/2.
Negative 1/2. Very good. So now we have to find the tangent of t. Well, we know tangent is y divided by x, right? So what did that be? The square root of 3 over 2 divided by negative 1/2. Excuse me, bro. Now, do you think we're going to leave a fraction within a fraction? No, that's why I taught y'all how to simplify complex fractions. So I could rewrite this like I did the other day. Square root of 3 over 2 and then use the division symbol by negative 1/2, and then we could do cube change flip or whatever. Or we could just multiply the numerator of the big fraction, or we can multiply the numerator of the big fraction and the denominator of the big fraction by the least common denominator, which would be what? 2. So those 2's will cancel. And we will be left with the square root of 3 over negative 1. And do you ever leave a negative in the denominator? No, what is the square root of 3 divided by negative 1? Isn't that just negative square root of 3? Okay. So that would be the tangent of t. Helpful so far? Yes, that's really excellent. Okay, so now let's find the cosecant of t. And we just wrote on our previous page that cosecant is 1 divided by y. Okay, so that would be 1 divided by square root of 3 over 2, would it not? All right, don't I have a fraction within a fraction? Let's get rid of it. We can multiply the top and the bottom of the big fraction by what? 2. Now, in the denominator, the 2's cancel. In the numerator, there wasn't a fraction there. So 1 times 2 is 2. In the denominator, the 2's do cancel, and we're left with the square root of 3. Didn't I teach y'all you should not leave a radical in the denominator? You remember what the fancy words are that we use that describes the process of getting rid of the radical? We have to rationalize the denominator. You do not want to leave, it's like you can't leave a negative in the denominator, but it's easy to get rid of a negative. You also do not want to leave a radical in the denominator. It's like against the math rules. Okay, the math gods do not like that. Do you remember what I have to do in order to rationalize the denominator? All right, so say it again. What? Oh, cubed root? No, because it's technically it's not a fraction. It's not. I mean, it's not an equation. Yes. What do you have? Yes, exactly. If I multiply by 1, I don't change the meaning of the problem, right? Well, would you say that the square root of 3 divided by the square root of 3, is that equal to the number 1? When you multiply a number by itself, it's the number 1, right? So I can multiply by the square root of 3 divided by the square root of 3 and not change the meaning of the problem. I'm just going to change how it looks. Okay? So whatever the denominator is, make a new fraction. You're going to multiply. So make whatever the denominator is, you're going to put that in the denominator, the numerator, and the denominator. So multiply fractions, multiply straight across. What is 2 times the square root of 3? It's just 2 square root of 3. I can't multiply the 2 together and the 3 together because 2 is outside of the radical and 3 is under the radical. And then what's the square root of 3 times the square root of 3? Isn't that the square root of 9? And what's the square root of 9? 3. Can I reduce the 3 that's under the radical and the 3 that's not under the radical? No. Now, if 2 and 3 were reducible, neither of them are under the radical, then I could reduce that, but they're not. So that's my answer. So when I give you your assignment, you don't leave negatives in the denominator and you don't leave radicals in the denominator. Okay, you always point to that. So that is cosecant, 1 over y. So let's find the secant of t. And just to remind you, we read this on a previous page, secant is 1 divided by x. So in this case, that would be 1 divided by x is negative 1/2. You're not going to get very many points if that's your answer, if you leave it like that. We don't want a fraction within a fraction. What can I do? Multiply top by 2 and bottom by 2. So that gives me 1 times 2 is 2. Over in the denominator, the 2's cancel. I'm left with negative 1. And what is 2 divided by negative 1? Negative 2. Boom. Any questions about that? All right, we have one more, cotangent. Oops. Cotangent of t. That looks weird. Cotangent of t. Okay, so cotangent is y divided by x. Cotangent is the reciprocal, which is x divided by y. So x is negative 1/2 divided by y is square root of 3 over 2. And that 2 is not under the radical, only the 3. So let's don't worry about getting rid of the radical first. Let's worry about getting rid of the fractions. So I'm going to multiply the numerator and denominator of the big fraction by 2. So my 2's cancel in the top and the bottom. So my new numerator is negative 1. My new denominator is the square root of 3. Is that my answer? No, I have to rationalize it. So I'm going to multiply by a fraction. And what will that fraction be? Square root of 3 divided by the square root of 3. So my numerator, negative 1 times the square root of 3. Isn't that just negative square root of 3? And denominator, square root of 3 divided by the square root of 3 is 3, because it's the square root of 9, and square root of 9 is 3. Can I reduce those 3's? No. Then that's it. Wasn't too bad, was it? All right, anyway, so writing that one, have a question. All right, example 2. I'm going to put that on a separate sheet. I'm going to label this page. The period. It is December 10th. All right, use the figure below to find the values of trig functions at t. All right, well, what is the sign at t?
1/2.
1/2, thank you. What is the cosine of t? Square root of 3 over 2. Oh, not t, 2. And the tangent at t, we know tangent is your y divided by your x, right? 1/2 divided by square root of 3 over 2. And we will multiply the numerator and denominator of the large fraction by what? 2. Am I going too fast? A little? Okay. So we have, in the numerator, we just have 1. In the denominator, we just have the square root of 3. Is that how we're going to leave our answer? No, we can't leave a radical in the denominator. So we're going to rationalize it. And we're going to multiply by a fraction. Square root of 3 over 3. Square root of 3 over square root of 3. So 1 times the square root of 3 is the square root of 3. And the square root of 3 times the square root of 3 is 3. Notice that made my radical in the denominator go away. I didn't change the meaning of the problem because technically I multiplied by 1. I just changed how it looked. That's like 1/2 is equal to 2/4. They look different, but they mean the same thing. Yes, because square root of 3 times the square root of 3 is the square root of 9, and the square root of 9 equals 3. Okay, but we don't just want to multiply the denominator by the square root of 3 because that's going to change the meaning. That's why you multiply the top and bottom of the same thing. Everybody cool with that? All right, let's find the cosecant next. Cosecant of t. Yes, you have to memorize what that means. Right now, I'm going to tell you. It's 1 divided by y. So that's 1 divided by 1/2. We don't want to leave our answer like that. That's a fraction within a fraction. So we're going to multiply the numerator and denominator by 2. Complex fractions. We had this on our last test. So numerator, 1 times 2 is 2. Denominators, the 2's cancel and leave me with 1. What is the cosecant of t? Just a 2. What? LOP? Oh, it's a t. The point is p. Point p. The angle is t. Right? That's the cosecant of the angle. No. All right, let's do secant of t. And secant is 1 divided by x. So in this case, that's 1 divided by the square root of 3 over 2. What are we going to do first? All right, multiply the numerator by 2 and the denominator by 2. In the denominator, the 2's cancel. In the numerator, 1 times 2 is 2. Denominator, we're left with the square root of 3. We're not going to leave a radical in the denominators. We're going to rationalize it by multiplying by the square root of 3 over the square root of 3. So what is 2 times square root of 3? 2 square root of 3. What is the square root of 3 times the square root of 3? Can I cancel out those 3's? No. If the 2 and the 3 were reducible, could we reduce those? Yes, because neither of those are under the radical. And one more for this one, we're finding the cotangent of t. And cotangent is your x divided by y. You want to find that one on your own? Dear the world. We'll compare answers.
Are we doing the assignment next?
I will do the assignment tomorrow. Just notes today. Y'all get what I got? Square root of 3? Anybody have questions about that one? All right, moving right along. So not everything is going to be at square root of 3 over 2, comma 1/2, or 1/2 comma square root of 3 over 2, right? Doesn't have to be there. Which leads me to number 3. So we're going to do the same thing. I'm not writing all those directions out again. Use the figure below to find the values of the trig functions. Oh, actually, it's a little bit different. Okay, use the figure below to find the values of the trig functions. I'm talking about all 6 of them at t equals pi halves. So this time it's not drawing it out for us. We have to figure out where t equals pi halves is located. Where is pi halves? How many degrees is pi halves? 90 degrees. Do we know where that is on the unit circle? Yes, so if we start at our initial side and rotate up basically so that our terminal side is on the positive part of the y-axis, that is where pi halves is, right? So that puts our point T up here. So what is the ordered pair at point T? What? Ordered pair cannot be infinity.
0, 1.
What is it? Thank you. So T is at 0, 1. We know that, right? Y'all are just not responding for whatever reason. Huh? No. Unit circle, 1 unit each. In a unit circle, the radius is 1. So it's not just any old circle, we're on a unit circle. Gotta keep everything covered over there. Okay, so, well, that should be easy enough, 0, 1, right? So let's find the sign of pi halves. What is it? 1. Easy. What is the cosine of pi halves? 0. Tangent of pi halves. Remember, tangent is y value divided by your x value. So that would be, what's your y value? 1 divided by, and 1 divided by 0 is, well, what? Last time I checked, you can't have 0 in the denominator of a fraction. So it's undefined. Undefined. You cannot have a 0 in the denominator. Undefined when you do. What if the 0 is in your numerator? Is that undefined? No, that reduces to what? 0. Yes. All right, so the cosecant of pi halves, remember cosecant is the reciprocal of sine, so that's going to be 1 over y. So in this case, that would be 1 over 1, which reduces to 1. Secant of pi halves, secant is the reciprocal of cosine, so that's 1 over x. Right, undefined because x is 0. That gives me a 0 in the denominator. We can't have that. Undefined. And then we have the cotangent of pi halves. Cotangent is the reciprocal of tangent, so it's x divided by y. So 0 divided by 1, is that undefined? That is 0. 0 in the numerator reduces to 0. 0 in the denominator, undefined. Coolio? All right, example 4. Just drawing a circle. So angle T is going to intersect the unit circle at point P. And point P is at the ordered pair of, oh, I'm sorry, I can't see that. Can you? Angle P is at the ordered pair of negative 15/17, comma, 8/17. At least they gave us one with a common denominator. So these are numbers we're used to on the unit circle, but that's okay. They don't correspond to any special right triangles, right? That's okay. We already know what the ordered pairs are, so we don't care really what the angle measure is to be able to find sine, cosine, tangent, all that stuff. So my sine of T is what? 8/17. My cosine of T is
Negative
15/17. Thank you. My tangent of T, remember tangent is y divided by x. So that's going to be 8/17 divided by negative 15/17. Complex fraction, no big deal. They have the same denominator. So that's going to be easy. We're going to multiply the top and bottom by what? 17. So that's going to leave me with 8 divided by negative 15. Can I reduce 8 and 15? No. Can I do anything else? Do I want to leave a negative in the denominator? Yeah, so just move it up to the numerator, right? Or right next to the fraction. So leave that as negative 8 divided by 15. Don't leave negative signs in the denominator. Right on? Croutons. Okay, so those are the first three that we work with all the time. We got that. So now let's find the cosecant of theta. Cosecant is the reciprocal of sine, so it's 1 divided by y. So that's 1 divided by 8/17. Wait, that's the big fraction. So we're going to multiply the numerator and denominator by what? 17. And the denominator, the fractions, or the 17s cancel. And the numerator, you just do 1 times 17 because there was no fraction there. So you get 17/8. Can I reduce 17/8? No, just leave it improper. If I could reduce it, then reduce it. But you don't need to turn it into a decimal or a mixed fraction. Just leave it improper. Y'all cool with that? Okay. Secant of theta is reciprocal of cosine, so that's 1 over x. So in this case, that's 1 over negative 15/17. Again, complex fraction, we don't want that. So we're going to multiply the numerator and denominator by 17. The denominator of 17 is canceled, and the numerator, 1 times 17 is 17, and the denominator, you're left with negative 15, but so I don't have to rewrite this. I'm going to go ahead and move that negative sign up. Are you all cool with that? Make sure when you turn in your work to me, sometimes I can't tell if it's just an equal sign or if it's an equal sign and a negative sign. I just can't tell. So please make sure that it's obvious if it's supposed to be negative, that the negative sign is separate from the equal sign. And then cotangent. See if I can fit that over here. So cotangent is reciprocal of tangent, so it's going to be x divided by y. So that's negative 15/17 divided by 8/17. We will multiply the numerator and denominator by 17. 17's cancel. And what is my cotangent? Negative 15 over 8. There we do. There we go. There we do. All 6 trig functions, just like that. No big deal. So I have one more to do. Actually, I'm going to let y'all do it on your own, in your notes, and we're going to compare. Okay? One more. So this is number 4. Was it 5? No, you're right. Number 5. Trigonometric functions. We're keeping you up. At theta equals pi, force occur frequently. Use the unit circle to find the values of the 6 trig functions we learned today. And I'll let you go from there. So did it tell you the ordered pair? No, so you don't have to find that, right? Can y'all do that? Yes, you should be able to. So at the answers, what was the time? 42 over 2. First of all, pi force is 45 degrees, right? And so cosine is also 42 over 2. And what is the tangent? 1. It was 3 miles. And then I got for cosecant. Y'all get 42 over 2? Yeah. And then secant, the same thing, so I do math all over again. It's 1 over 42, right? Then cotangent, again, is the same thing as tangent. It's also 1. Cool beans. Don't have any questions? Comments? Concerns? Are you ready for lunch? We have 2 minutes. So, not going to do it today. We'll save our assignment for tomorrow, unless y'all just really want homework. No, me either. I got enough grade to do it as yet. So, we will save the assignment for tomorrow. Those of you, as soon as you have this called down, if you don't have any questions, you can log off. I'll end the video shortly so that I can get it uploaded to YouTube and then on to Schoology. Everyone has an amazing day. Alright, the video. Or at least I'm going to stop recording. Try to stop recording.